Hello everyone! Welcome to my channel where I teach you how to be a math genius. If you typically struggle in math or you're looking to improve your understanding of math, this is the channel for you. Also, I will try my best to make these videos user-friendly for teachers, co-teachers, or homeschoolers to utilize as well. If you fall into any of these categories, make sure you hit the subscribe button and that notification bell so that you're notified anytime I upload a new video. Now let's jump in. Today we're going to learn about some basic vocabulary typically used throughout algebra. I want to begin by explaining these terms since I'll be using them often in some later videos, and I find these are some terms students typically struggle with fully understanding. By the end of this video, you'll be able to define each word and create examples of your own. I encourage you to write your examples in the comments for practice, and I'll respond to you to let you know if you wrote them correctly. Now let's get started. The first word we have here is sum. I'm sure you've heard of this word before. It refers to the solution to addition. Then we also have difference, which refers to the solution to subtraction. The reason why I wanted to go over these words is, though we know these two, a lot of times we trip up this one, product, which means the solution to multiplication. And sometimes we forget this one, quotient, the solution to division. So I just want to make sure that I reviewed all four. Now let's dive deeper into these four terms. So the first word we said is this sum, which is solution to addition. So what if we had something like 7 plus 3, which we know is equal to 10? What if we had this equation? Well, that means that 10 would be considered the sum of 7 and 3. What about if we had something like 7 minus 3? So 7 minus 3 is equal to 4, which means that 4 is the difference. 4 is the difference between 7 and 3. Then we also have the product. The product would be something like this. So what if we had 7 times 3? We know 7 times 3 is equal to 21. So then we could say 21 is the product of 7 and 3. And lastly, we have the quotient. So an example of this would look like something like this equation. 21 divided by 7 we know is equal to 3. Therefore, 3 is the quotient. 3 is the quotient of 21 and 7. All right, let's look at a couple more words. So now we have the word expression, which refers to the combination of symbols, operators, and numbers. And then we also have the word equation, which is two expressions set equal to each other. Now let's explore these two words. So an expression is a combination of symbols, operators, and numbers, and the equation represents two expressions. What's the big difference between these two? Well, the difference is this, the equal sign. An equation has an equal sign, and an expression does not have an equal sign. Let's look at some examples of expressions. An example of an expression could be something like this: 3x plus 8. Or we might have something like this: 4y minus 9. Both of these are examples of expressions. Why? Well, we have some symbols, x or y. We have some operators, plus, minus. And think of operators like operations. We have the operations addition, subtraction, multiplication, division, right? And then numbers. We use 3, 8, 4, and -9. Now, what if we wanted to make these two expressions one big equation? Well, we would have to set them equal to each other, like this. 3x plus 8 is equal to 4y minus 9. This one big thing is considered an equation. Why? Because it has an equal sign. And within that equation, we have one expression on the left and one expression on the right. All right, let's look at the next words. So we have the word constant, which is a number by itself, a variable, which is a letter or symbol representing an unknown number, a coefficient, which is a number to the left of the variable, and an exponent, which is a number at the top to the right of a variable, or a number or an expression. An exponent is also considered a power. So exponent and power mean the same thing. So let's dive deeper into these four words. So a number by itself is as basic as it seems. 1, 2, 3. Any number you can think of is considered a constant. We consider this a constant because it constantly represents the same value. It'll never change. So a constant will never change. 1 will always represent 1. 2 will always represent 2. 3 will always represent 3, and so on and so on. But then we have something called a variable. This is a letter, not a number. It's a letter or a symbol representing an unknown number. So it represents a number that we don't know yet. So if I'm referring to a variable, it's representing a number, but we don't see a number. So what do we see instead of a number? We'll see a letter such as X or Y, or a symbol such as theta. Now, theta is typically used in geometry, so we're not going to touch too deep on theta. But X or Y, letters, it could be A, it could be B, it could be C. And why is this considered a variable? Well, it's because the values of each of these variables may vary. What do I mean by that? They may change. So in one equation, you might have an equation where x equals 5, and then you might have another equation where x equals -10. Those are two different values. And so that's why the value of these letters or symbols may vary, and so we call them variables. Then we have a coefficient, which is a number. So a constant is a number, and a coefficient is a number. A coefficient can only be a number. It's not a variable. So it usually sits to the left of the variable. So if we have something like this, in this case, we have the variable x, and then we have the coefficient 7. Why is 7 not a constant? It's not a constant because it's not by itself. 7 is not alone. 7 has an x beside it. Therefore, 7 becomes a coefficient. If 7 was alone, it would be considered a constant. What about this? In this case, we have the variable y and the coefficient 8. 8 is a coefficient because it is to the left of the variable. It is not alone, such as 8 by itself, which would be considered a constant. Then we also have a number at the top to the right of a variable, or a number or an expression, which is considered a power or an exponent. So if I have something like 7 squared, or 7 to the power of 2, that 2 is your exponent. What if I have 7x squared, or 7x to the power of 2. That 2 is your exponent. Why? Because it's small and at the top to the right. You can also have an exponent at the top to the right of an expression. So in this case, our exponent is 2. We can also just have it sitting at the top to a variable. So another letter. Your 7 is your exponent. Your g is your variable. Next, we have the word term, which refers to a single math expression. So this is considered a term. It's a single math expression. It's an expression, but it doesn't have any operators. It doesn't have a plus or a minus, or it could have a minus if that 3 was negative, but it doesn't have times or divided by any other term. It's just one piece of an expression by itself, and so this is considered a term. This is also considered a term. -5. So any of those things that we wrote earlier, 7x, 8x squared, 5x, -3, 10, any of those things can be considered terms. And when we put them all together, they make an expression. So we have this term -5, which is also considered a constant. So the type of term that this is a constant. Why? Well, I want you to guess why. Go ahead and pause the video and guess why you think this is a constant. If you guess that -5 is a constant because it's a number by itself, you were correct. Now we have the other term, 3x squared. And 3x squared is not a constant. It's actually made up of a couple of things. It has a variable, which is x. It also has a coefficient, which is 3. So the coefficient is also a number, but if you guess that it's not a constant because it's not alone, you were correct. Then we have 2, which is another number that is not a constant because it's not alone. It's small and at the top to the right of the variable, therefore it's an exponent. The last word we have here is like terms. Like terms are terms that are alike in that they have the same variable and exponent. Now, what do I mean by like term? Let's dive deeper into this. So what if we had something like 3 and 12? 3 and 12 are both alike. They're the same type of term. They're both constants. And though terms need to have the same variable and same exponent, neither of them have a variable and neither of them have an exponent. So they share that in common. They're alike. These are like terms. What if I had 3x and 12x? Well, these are like terms as well because they both have the same variable. And neither of these terms have an exponent. So these terms are alike. What if I had the two terms 3x squared and 12x squared? Well, these terms are like terms as well. Why don't you take a pause of the video and guess why? If you guess that these two terms are like terms because not only do they have the same variable, an x, they also have the same exponent, a power of 2, then you were correct. Good job. What if we had something like this? Well, these are not like terms because 3 is a constant, meaning it's a number by itself. And 12 is not a number by itself. It's actually a coefficient because it's not alone. It has an x. And so 12 has an x and 3 does not have an x. Therefore, these are not like terms. What about 3 and 3x? Well, these share the same number, but they're not like terms. One is a constant and the other one is not. Here we have a constant, a number by itself, and this has an x. What if we had 3x and 12x to the power of 2? Well, these are not like terms because 12x has a power of 2 and 3x does not. So, though they have the same variable, they don't have the same exponent. Therefore, these are not like terms. Think about the example 3x and 3y. Well, these two terms are not like terms either because though they both have a variable, this one is an x and this one is a y. Lastly, let's look at these two examples. So I encourage you to take a pause of the video and guess why these two terms are not like terms. If you guessed that these two terms are not like terms because though they have the same coefficient, the like term definition does not worry about coefficients. They also have the same variable, which checks off a component of like term, but they do not have the same exponent. One has a 5 and the other has a 2. Therefore, they are not like terms. If you like this explanation on basic mathematical vocabulary, make sure you hit the like button below and don't forget to subscribe. Thank you everyone so much for watching my video, and I'll see you all in the next one.